Hello and welcome to the next Global AI Community session. Today we're talking about robotics, and I'm happy that Marc and Bernard are joining us today. Thank you for your time, guys, and it's really great to see you again.
Thanks for having us.
Thanks for having us. Yeah, good to see you again.
Thank you. So we will speak in a few minutes about robotics and also why this topic is also important. But first, we need to introduce the global AI community. This is a company, community based from the company's side, pushed also by Microsoft, but also from other companies around the world. And we are the biggest AI community right now. So we have 106,000 members already worldwide. The community is running since 2018, so before the COVID, and there are already 180 groups connected, and we have a lot of meetups, a lot of chapters who are running the events, and there are almost 4,600 or perhaps almost 4,700 events already taking place since the beginning from 2018, and this is one of our community hubs. So for example, we are doing events online like this one to push the technology, but also in person in different cities like Berlin, where Marc is coming from, Cologne, Bochum, Karlsruhe, Munich, Nuremberg, Zurich, also Würzburg. There are some cities here in the region from Germany, from Switzerland, in Vienna, from Austria. And to be short on this, we have a call to action, of course. Be one of us, learn more about AI, meet, find, and join your chapters, your city. If you see on the global AI community website, there's no AI chapter in your city, you can become active, get involved and grow, also become the leader and start your own chapter. But today it's about robotics. And that's why we have Marc and Bernard with us. And let's talk about robotics. Why this topic is, for you, from your side, the most interesting thing you are doing.
Well, from my point of view, maybe robotics will be the next wave. I mean, we are currently in the wave of AI. There's also surely some hype in this, but I think AI will be an enabler to do robotics in the next step, and this is then where AI really becomes useful. I mean, it's already useful today, having support for software development and document analysis and whatnot else. Yeah, but I think it enables robots to act hopefully in an intelligent way. So at least
but if we're
that's my
talking
hope.
about robotics somehow and going perhaps 50 years ago, we started already using some robotics perhaps on Mercedes, or if you are going to build a car, there are already robotics there. There are already running systems. So before AI was there, we talk about robots.
Yes, that is actually a topic where I probably will talk about a bit. But I think, first of all, obviously I agree. So Bernard basically made the point that all the pieces are now there and robots will be then kind of like the next big thing. And for now, we do have the robots and we have them for a long time. But think again, we also had machine learning for a long time before the transformer models were there. We had like computer vision for a long time that helped us. And I mean, think about your PhD thesis. It was about NLP, which is superseded by transformers. So since the technology evolves and keeps in being pushed and pushed and pushed, now we are like maybe at this point where the robots maybe become, I mean, they are useful already, but maybe become or go to the next stage. And plus, I mean, what is Skynet without the Terminator, right?
Just a software.
We need robots for the world domination thingy.
Yeah, true on this. I agree. We tried 10 years ago to code with your natural language somehow before ChatGPT was there. And after ChatGPT arrived, nobody asks again about why do you want to do this with your natural language. So somehow it was clearly for all of these things. And I liked also what Bernard was saying. The robotics are there. Now you add AI. There's another piece on technology stack. And now you have all of the pieces to get in an intelligent way. So to talk about robotics, what I was mentioned earlier was perhaps 30 years ago. It was just automation of something what I have done by a human. Now I can build a car with some robots, but it's not an intelligent somehow.
Yeah, I'm with you. I think also robots enter more dynamic scenery. So first we have these robots on car manufacturing where you put it in a cell and protect it, and they automate things, but they do it in a predefined area, kind of, where we know the preconditions, and then we can automate it. But I think more and more use cases will come where the robot is kind of mobile, acts in an environment that he only partially knows, and then he has to have some hopefully intelligent way to behave.
To adapt to this new environment. But Marc was saying about the Skynet. Let's imagine we are 20, 30, 50 years in the future. What would you expect what robots should do, not to break the system like a Skynet somehow, but perhaps to help the humans on the way, also on the AI path?
I guess they will be a commodity. Like, I mean, think of the model use. Like, remember when we had our very first session together, and I was like, yeah, so I guess the models will become more smaller, more specialized. This is a trend that we actually see right now already. If you, for example, there's like this project where they use like smaller models but put them right into hardware, right? So they build ASICs, and those are like insanely fast. And I guess we will also see something similar with robots at some point, like with these customer-centered robots. I guess industrial robots are still like a different type of thing, but these customer-centric robots, they will be probably not multi-purpose robots that can do your laundry, that can cook for you and take care of your cat. But then you may have like multiple small robots. One of them is taking care of the cat litter. One of them is doing kind of like the cooking or the kitchen stuff. And one of them is kind of like doing the laundry thingy or making you coffee or whatnot. But like these very specific. And I guess they will be kind of like these, I don't know, the way you order nowadays, maybe a phone or something. So there's like a new generation of phones where there's a feature that you really like, or a new generation of dishwashers, and then you get this one because you are tired of your old robot that does not do this particular way. That's
do you compare this one to AI agents or like systems what we are built today to help us on daily stuff, like get me something in your natural language, then you get your summary or whatever, or coding also. You will expect robots to be there and help in real world somehow on a daily tasks.
Yes, if they're not revolved before, then this is the future. I will see.
You're still on this Skynet path, I think. Yes. Bernard, what do you think about this future vision from Marc?
Difficult to say what will be in the future, but I mean, we see already some kind of domain-specific robots now. Your floor cleaner, something for the outside, and maybe we keep with them. I don't know. Maybe we get some more general purpose robot which can do not specialized things, but more general things. And maybe not everybody has a robot, but you have you can order for a certain time a robot, like we do it maybe in a few years with the cars, because I think it will be kind of same, you have your car, most of the time it's in the garage, and not used.
You don't need this. Yes.
You don't need this, yeah. And then a rent on demand model is, I think, the way to go. And I could imagine that the same is with robots, because you won't need it maybe the whole day, yeah, in your house.
Okay.
But I still think this multi-purpose robots are very challenging to build. And I mean, obviously we can't extrapolate the future from what we have right now, but there are a few, like they have been introduced a few multi-purpose robots, humanoid robots lately. And what happened is, yeah, technically they can do this, but most of the time a human needs to intervene because the tasks were just too complex, the space were just too complex to navigate, and all these type of things. And it's just so much easier to have a single purpose vacuum or laundry folding robot or dishwasher or these type of things, and build this and sell this to the people, than bringing them to, like, hey, give me 20,000 euros and you have this multi-purpose robot, but sometimes we actually need to jump in and make it unstuck. So that's why, I mean, it would be great, right? So we have been grown, we grew up with these like science fiction stories of these multi-purpose humanoid robots, but I'm afraid I think this unfortunately is nothing that we will see unless we have like plenty of money to spend on this and can be like, yeah, so like this fancy humanoid robot. But that's just my take. I don't know. It's crystal ball reading.
We also have some already comments on our discussion from Francis. Thanks for agreeing on this one with Bernard. AI will definitely going to be an enabler across all of the domains. Yeah. That's true. And I think the stage is great set, and we dive into the first talk, I would say. And Marc, you are going to present us RoboTwin and teaching robot at scale. Thank you to the stage, and we're looking forward to this.
All right. Great. So, for those who joined late, I'm Marc Plogas, and I'm the cloud and IoT guy at a company called RoboTwin. We are, wait a minute, no. We are a startup-based, a Prague-based startup. We are on the market since 2023. And we are developing and delivering hardware and software products for robot teaching. Our focus, however, is not on the humanoid robotics side, but rather on the manufacturing industry. And so we have won the prestigious EIC Accelerator award in the last batch. So other people see the future in what we do. So let's start easy, because this is like a picture from 70 years ago. This is the small company called Skoda. Yes, I know that's not too small anymore. Now it's part of the Volkswagen Group, and they have and had several production lines in the Czech Republic. And this is basically how they used to build cars back then. Obviously, car manufacturers are known for, used to be known for having big budgets and producing in large series. So for them, it actually should pay off to invest in optimization and digitalization, automation, and of course, robotization, because a robotized production line is usually a lot faster, more reliable, and that is important part, repeatable quality. And that's why, for example, at Skoda, there are more than 4,000 robots at work today. But let's have a look how this looks nowadays. It looks basically the same. 5 people. Now they are smiling. They weren't smiling 70 years ago, but there's that. And not a single robot, as you can see, right? So, and this is the point, right? So for them, robots are basically these machines and tools, and to make them useful and to do what you want them to do, you have to program them. And some operations, for example, like assembling a car or a dashboard, are simply so complex to program that it becomes incredibly difficult. And especially when it comes to robot programming, the picture on the left side is what it looks like today. This is like not a 20 or 30 years old picture. This is like reality right now. Most robot programmers have these like this size controllers where they click some commands in combination with some buttons, and it's basically, if you're as old as I am, you remember the Nokia phones with the physical buttons where you were using T9 to write SMS. So that is basically what you do there. You have like multiple functions on a single button, and you have to know what happens if you twist it twice, and so on and so forth. And all you do is basically move the robot into different position and then fine tune it one step at a time, and basically super slowly create the movement you want it to do point by point. And obviously you do not have to, if you have like two different points, you do not have to do the part in between. You can actually just say go in between. But if you have, for example, some obstacles in between or constraints in between, then you will go and define multiple points around the obstacles. So this is very, very challenging and time consuming. And you may think like, hey, wait, we are in 2026. I mean, come on, digital twin, computerization, and so on and so forth. Why isn't this there? And I can tell you, well, it is there. We do have a digital twin. This is how the digital twin looks like. And this is how the programming looks like. You do have a tool, but instead of clicking buttons, you just click the buttons by mouse now. So that is really not like, there is no additional usability, and it does not have become a lot easier and better to program the robots. And this is kind of like the thing in the industrial robotization, right? So it takes up to a month to tune a robot trajectory for any new product. And the issue is that the robot programmer oftentimes lacks the inherent knowledge of the people from the factory floor. And of course, the people from the factory floor often lack the knowledge to program robots. And that results in the fact that the robot is only utilized by 40% on average, which is obviously, in terms of return of investment, kind of like a bad deal then, right? And then if you really want to replace skilled workers with robots, you need a robot, and you need to hire a robotics engineer or a robot programmer in that case, and they are even more expensive. So actually you do not really gain something. So it comes as no surprise that McKinsey states that the second important or top challenge related to automation is actually the robot programming, which in turn then, this is kind of like the typical picture in European manufacturing. Demanding, dirty manual labor is still there. And on top of that, due to the aging of society, we are losing qualified people every month. So manufacturing struggles, people are missing or lacking, or we don't have the skilled workers. And obviously robots are not there yet. So how do we move forward from there with the automation part? Like, what is the next big thing? We talked about this a bit earlier already, like where do we see robotics in 20, 30, 50 years? If you basically go to right now, the International Federation of Robotics publishes what trends it sees for the next year. So this is from 2025. And it's also very interesting to follow their predictions year to year. And for example, last year, they predicted that for the first time, not that the robots are taking people's jobs, but they are basically addressing the labor shortage because people are just not there yet. And it's also interesting that last year, so like in 2024, for 2025, one of the trends was all-purpose humanoids. We talked about this as well. And this year we have kind of like lowered our expectation. And now the purpose is just, now the idea is just single purpose humanoids for a start, because like not the humanoid servant I talked about before, but because this is just too complex and too complex to ask them to make coffee, do the dishes, and fold your t-shirts, right? I mean, of course, then there's also some AI, and we do have high hopes for AI in all the different fields. And of course, in robotics, we hope that it makes the programming a lot easier, the machines smarter. But we get to the challenge why this is not as easy as we think it is. As you can see here, folding clothes is kind of like the go-to example or top example of the robots. It's, I mean, either folding clothes, washing dishes, making coffee. And it's absolutely impressive what these machines can do, or in what it does right now cannot do. As you can see, it struggles with picking up the shirt. But on the other hand, we'd much rather have robots that replace the painters, the grinders, the welders, and all those people with hard and dirty work, right? So, and until we have reached that point, from at least from industrial point of view, it's probably better just to make our own coffee and focus on replacing those jobs or improving those jobs. Which also brings me to the question, why are we only focusing on folding clothes and making coffee and not how to assemble a dashboard in the car? And that is kind of like the biggest challenge that we see in robotics nowadays, because we don't have the data for all the like industrial automation. And Physical Intelligence, the company behind the robot from the previous video, actually openly admits it, right? So, I mean, ChatGPT and the likes could learn from an internet full of text, articles, Wikipedia, Stack Overflow, GitHub, and whatnot. Basically, an endless stream of digital content. But there is no such treasure trove right now for robot data. There is simply nothing like this. And this is basically where we in RoboTwin started to jump in and try to kind of like, with a first step, try to gather the data so we can go for the actual real or second step. We kind of like help people teaching this kind of like tie-in and small, it's not really advertising, but it's just like to show you what we do. This is basically our device, our sensors, our hardware and then we also have an app. And this is basically what helps people programming robots. So by that, we also create our own treasure trove of robotic data, right? So we give people these tools, the workers these tools, and have them demonstrate the operation they want to robotize. In this particular example, for example, painting. And then we collect all the data during this process, and then we generate a program for the robot, and it can then start producing the rest of the series automatically, as you can see it right there. As I said, this is kind of like our immediate solution, right? So empower the human workers to teach robots directly by imitating or demonstrating the desired movement. So that is basically step one. The next step, however, or the ultimate solution is a program or an approach where we generate robot programs automatically. So we have the sensory data from the factory workers. We have the recordings from how they do their job. And based on their inherent know-how, we have started building a model that we have built a model that generates robot programs fully automatically, basically just from the 3D scans of the product. Obviously, the advantage that we have is because we had like this previous step of gathering all the data from real production, from real skilled workers, from the factory floor itself. So that was basically, that is basically the foundation of what we, for this particular step. Oh, yeah, okay. So sorry, there seems to be a bug in the slide. Okay, so that was the fancy picture for that, but what I said still is the same. So as you can see, we start scanning this, we generate stuff, and we use the teaching, the supervising, and then automate the step. But let me take a step back and detail the old system, right? So you can see on the left-hand side, the spray gun, it's from a painter, sends data to this like bluish edge unit that you're carrying, where we pre-processing some of the stuff that the human is doing, like poses, velocity, paint flow, like depending on the job the people are doing. Then we send this pre-processed data to the cloud, to the backend, and then the user manually triggers the system and converts this human, like this recorded human trajectory into a robot trajectory. And then the program is just downloaded and made available to the robot in this particular robotic language, which is also kind of like a differentiator, because we are not requiring the robot to be flashed with a new operating system or something, which is usually, I mean, it's a 500,000 euro robot. You do not jailbreak your robot just for the fun of it. So what does it solve? Like for now, it solves instead of weeks of joystick code tweak and simulation, you get basically this usable program in hours and tune it within a day or two. But still, and this is kind of like the important distinction here, the flexibility with the old approach or with the teaching tech approach still comes from the human brain. If the object or the setup changes, even by a tiny bit, the skilled painter or the skilled worker needs to do a new demo, and then the system generates the new path. Obviously, this hits a ceiling. That is pretty clear, because fundamentally, it's still human first, right? So you must demo every variant you care about. And if you have a customer, or if you are a customer that handles hundreds or thousands of unique parts every month, and we do have those, they cannot spray, grind, weld all of them manually just to teach the robot. And this uniqueness is really tricky, because sometimes it's just a size change or a minor geometric tweak. I mean, obviously, this is a spectrum, right? It can be from a completely new shape to just like minor tweaks, and it's still considered unique. The bottom line is basically the direct teaching, the old approach solves the time to first program problem properly, but it does not solve the data scale and the geometry generalization problem, which brings us to the new approach, where we are evolving from an algorithmic post-processing of human motion to ML-based trajectory generation from 3D geometry. And the human in the loop is no longer a teacher, but a supervisor. And this is basically increasing the flexibility and scalability of the entire process. So how does it work? Obviously, we still need initial data gathering. So we get, preferably, if that is possible, we get the CAD model as well from the part. It's not needed, but it would be better. I get to why it's better in a bit. And then we also do a 3D scan of the part. So basically you have how it should be and how it is right now, parts of the part. They are collected independently. Then we process or pre-process them on Azure. So we send basically this data into to small containerized workers on Azure. These workers just do morphological analysis on the geometries. And since those are like independent workers, we can actually, for example, for batch processing, we can scale them out horizontally without any issues. Then we talk about environment calibration, because these robots, as you can see, they sit in a cell, and we need to know the robot base, parts, tools, limitations, and so on and so forth. And obviously also the limit of the robot arm and that setup. And obviously, because we talked about, industrial robots sit in a cell, and that is a good thing, because these things are not like these tiny SO101 little robot thingies where they just like a pinch a little bit. If those things move and you're in the way, they still move, and you don't move after that anymore. So that is kind of like the thing why its safety is so important with these things. And that's why we also need this environment calibration to make sure there are boundaries that the robot cannot move across, right? So once we have all this data, like the CAD data, the pre-processed data and the environment data, we can actually go ahead and start with the program generation. So we have an ML model that does like this object-centric motion generation, which predicts trajectories directly executable by a particular robot in the target environment. So we can actually say, hey, let's generate a program for this like left yellow robot, and then the program, or then the algorithm or the model will actually generate a robotic program for this particular robot, which then work, and then he can spray, paint, grind, whatever with the model. We do have two different versions of inference. Obviously, there's like batch. I talked about that we have batch. We can actually also do real time, or near real time. Obviously, it's not like that we predict every step, but we also always predict the entire trajectory. So that means near real time, it probably takes a few minutes until you get like the entire path. We use Azure ML for training, but the inference is actually really light. It runs on T4 GPUs on Azure. So yeah, the inference is actually not a big issue anymore. This approach is obviously really, really scalable because we are no longer bound to one demo per part, right? So and this is also something that is important to understand. We have one geometry can usually support several valid trajectories, right? So there is not like this particular single trajectory that is the only valid one, but it can be 2 or 3 or even 10, right? So still correct, but different paths are there, and our model can actually generate them all. So you could go ahead and say like, hey, by the way, give me the 3 most likely trajectories that work. And then you can go ahead as a supervisor for this particular part and say like, you know what? I don't like the first one that you consider the best one, but I like the second one. And then you just pick that one. So you can have your personal touch or constraints bringing in for the path or trajectory generation. Which brings us to the huge amount of challenges that we were facing in developing this. Obviously, the most important one I already mentioned, it's the data scarcity. We don't have an internet of robots, no ImageNet, Lion, or whatever equivalent for industrial robots. And even if there are robotics or public data sets for robotics, they are about everyday human activities. And they are mostly 2D and RGB. But there are like no 3D point clouds, no industrial 3D point clouds where you can start training on, right? So, and it's not that the data is not there, but they always live in silos or islands, right? So each factory floor, each robot brands, each integrator, they all have their treasure trove of data, of silos of data that they do not really want to share, that just sit there not being used at all, and so on and so forth. The next challenge that we were experiencing is obviously the ground truth. The ground truth is basically, let's call it the baseline, right? So if a spray painter here in that picture paints a piece, that is kind of like the 100%, right? So if it looks like this, then you have achieved your goal. Usually, this ground truth is locked in human knowledge or human wetware, like the brain, right? So we can kind of like get it in parts with the teaching tool that I showed earlier. They provide the trajectory ground truth, but obviously it is limited to tasks and sites where it is deployed. And also, it is quite expensive to collect at scale. And I mean, not the licensing fees from our end. I mean, they may be expensive as well if you do this like in bigger scale, but also the time that is very time consuming, because if you have like thousands of parts, that is very time consuming. And also you need skilled workers, right? So someone needs to spray paint, grind this, and so on and so forth. So that is like, as I said, like it's really expensive to collect at scale. You can obviously complement this with synthetic data, like synthetic objects, synthetic trajectories, but you still need someone who verifies even the synthetic data that you get from this. Then I talked about the other big challenge is the geometry granularity. I talked about unique parts that can mean same geometry, different size. If it's just like 95% of the size, if you think about these, let's say these things that you can see on the screen, if it's like just 5% smaller, that is actually noticeable. We have slightly different geometry, like new holes, edges, cutouts, threads, all these things. You cannot just like polish or grind over these holes. You need to know this, and then you need to have like a different trajectory and so on and so forth. And as I said in the beginning, that is kind of like a spectrum, right? But it's still unique parts or geometry granularity. And then because obviously on the like very outer part, you also have like entirely new shapes for which you need to train and so on and so forth. And then, and this is kind of like often overseen, material and perception issues are also a thing, right? So if you were into the game of depth perception when HoloLens were still a thing, you know, for example, shiny and reflective surfaces are a no-go. Black or matte black surfaces, oh man, they are the worst, right? So, and also, I mean, and on factory floors, we also have dust. Dust complicates scanning of objects. And that's why we also recommend using the 3D model, like the CAD model as well. So we have kind of like a comparison and can start matching those models in order to also see the details that may have been lost during the regular scanning. And yeah, I mean, and that obviously means they also mentioned this, existing models for these like trajectory predictions and so on and so forth. They were mostly trained on 2D, and extending all of this to voxels or point clouds is actually still something you can write your PhD thesis about, because it's an active research area. And obviously the elephant in the room, because we're talking about manufacturing, data governance, of course, models from the customers. It's a legal nightmare, obviously, to discuss this with customers, because their CAD scans trajectories. Sometimes they don't want this stuff to be used. Sometimes they require custom-specific ML models, machine learning models for competitive or safety reasons, and so on and so forth. Then all the trajectories, all the CAD models cannot be technically stored all the time on our cloud, only basically for the path generation. Yes, we also allow this, but by default it does not. So it is a bit challenging to convince the industry that there is like a need or a benefit actually of storing these things for longer and reusing it for training. But yeah, that's kind of like the data challenges that we are or were experiencing. And then we also have like a fun thing in the infrastructure challenges. I mentioned it's industry, right? They are rather conservative, so they are not really cloud first, and therefore our paths need to be generated online, but need to be downloaded immediately, so they can integrate this into their existing on-premise customer, like a custom robotic management solution. And this is really challenging. And then obviously the execution of the plan should not be, of the trajectories should not be depending on continuous connectivity to the internet, because there is usually no connection on the factory floor, and there should not be any runtime penalty if the cloud or if Azure is down, which is of course never happening. And another thing, for example, we learned, because we thought like, yeah, I mean, real-time inference is probably something that is really interesting, and we started with that, and then realized that many customers want batch mode generation. So they basically generate scans of multiple hundred parts, and then they are going like, okay, so it's 8 p.m. See ya, we want to have the trajectories tomorrow. So we as a company need to scale this out in the night, like off-peak hours, where we then do the heavy compute. And then this results in the robust cloud infrastructure that we need, and also have clear failure modes when Azure is down, and so on and so forth. So that is kind of like the cloud challenges that kind of now tie into robotics here as well. Now, where does it bring us? It's basically with previously our path were directly interpretable as what humans did. So, and it's also easy to reason about, because when a human did this, it usually works. And then with the new approach, with the neurofabrics approach, this is how this product is called. These model generated paths now need stronger safety and safety validation, because that means, this is what I meant with the human becomes the supervisor, because they need to verify in virtual environments and simulation that this, like, there is like enough that there's no collision, there's reachability is set. We do these things as well, but we can only have the information that we get, right? So if there is something that they totally forgot about, that needs to be verified on their thing. But it's basically the same if you use an LLM that says like, yeah, this information may not be correct, please verify. And this is what we say, like, yes, that likely works, but please verify so no human comes to harm. But obviously, if you have a supervisor that can verify a few hundreds or I don't know, like 100 trajectories a day or something, that still scales a lot better than demoing each thing and then getting the trajectory and then demoing the next thing and so on and so forth. And this is kind of like the shift that we see now from human moving from being a programmer or teacher towards becoming a safety supervisor or an approver of something. And finally, it's kind of like the call to action or call to participation. If that is something that you're interested in, if that is something that affects you or something like that, feel free to reach out to us. We have a pilot program. We are selecting a few factories now for the pilot. And also we are hiring. If you go to our website, we have a career site. So thank you very much.
And we have some questions. Thank you very much for this great talk, Marc. The first one would be perhaps on your mention about the robotics and the challenges. And the one of the challenge, what do you think would be changing from the challenge to opportunity somehow also can be solved next? Because if we're talking about data and we're talking about security, I don't think the data is the same in AI. It's every single time missing. So we can talk about AI. If there's no data, you cannot train your model. There's no there. If you're going for the robot, if you have no data from your environment, you will never done this. It will be still the challenge somehow in this environment. So what do you think will be changing from the challenge to, or can be solved next on this robotics, or also perhaps if we are using AI on this, what Krasimir was saying, thank you very much. So now AI provides us with new capabilities for build autonomous robots much easier. Yes, but the challenges are still there.
Yeah, so this is okay. So interestingly, this is something I am building. Okay, so now I'm probably not telling too much, but
I hope so.
No, it is not company related. It's kind of like a side project of mine that I'm basically doing. It's also with robots, and it's like the famous SO101 that I'm using, and also using AI. But it still boils down to, I do have an agent basically sitting on top, and that I can tell like, hey, agent, or like, hey, robot, pick this yellow Lego brick and put it into the blue box. That works. But this is only working because I do have a like classical computer vision model that detects a blue box, that detects a yellow Lego brick, that can kind of like, that has depth perception and can tell you where it is. But I still need to train all these. And this is kind of like bring us back to where do we get the data from? So the AI in that case is not necessarily solving the data plane issue. It is just adding a level of dynamic on top of it.
But what if your box will change from for example, your bricks will change from yellow to red or have a different form somehow. So you need to retrain. So you need to add these
Yes.
data to your models.
Yes, precisely. So yes, I would need to train my computer vision model to say like I can work with blue, yellow, and green and whatever Lego bricks on black or whatever Lego bricks or brown. So I would need to train it first so I can then reliably use these classifiers on my, let's say, orchestrating agent, AI agent that to use these classifiers. So that is required. So as I said, like it's still not solving the data issue, the lack of data issue, unfortunately.
Okay.
And yes, we have VLAs or VLMs. Unfortunately, how to put this? The throughput of these models is not high enough to operate in almost real time, because I mean, you know it yourself, right? So if you have a VLM running somewhere, it takes a few times, it generates lots of tokens, and then it gets the response, and then it needs to get this response, and it will never tell the robot, hey, move to this part. So it will never generate this trajectory. So but you still need this trajectory somehow to generate it. So you always have like these subsystems which control the actual robot movement. And for the control of the robot movement, you also need some experience, some maybe training. For example, if you think of the LeRobot project, they did training on these things and they leverage models internally on these things. But those are like regular machine learning models. And this is not like the fancy AI transformer stuff we're seeing there, unfortunately, yet. I mean, it may change in a few years, possibly. But right now, it is, I think the data issue still remains, unfortunately.
That is nice, but you also was talking about environment and also about data, but also about security. I'm wondering if the security is every single time a problem if you're talking about the system should be dynamic. That should do something what I was not teaching, like algorithm, just going deterministical from one position to another. Then I can guarantee it will be secure somehow because I have these boundaries.
Yes.
If we're talking about AI, we're talking about robotics right now, and I think Bernard will talk about this one also in a minute, about sensors, application development. The security part will be more abstract somehow if you are not just going for your text and not just moving from queries input output, so you can control output, but also putting like a robot who is doing things in your real world on how you will struggle on security. On your one picture, what you were saying, if the robot would replace the humans in this was one picture, you have to care about the environment, about the robots between them, and all of these things in lifetime, or to the real time somehow. And that was perhaps something what you will be also on the security path, also afraid how to solve this one.
Yeah, that's the classical. I mean, this is the same issue the autonomous driver, like the autonomous driving has. You can push it to, I don't know, make it 95% or 90% safe, but there's still like this remaining risk. And then who's responsible for this risk, right? So, I mean, obviously the AI is hopefully not doing it on purpose. I don't know. It's likely not doing it on purpose, but still there's this liability issue. And if on a factory floor, because we were vibe roboting, you heard it here first. Vibe roboting is a thing now. And someone dies, that is who is liable for that, right? So is it's a company that was using or producing the algorithms? Is it the company where the shop work that owns the factory floor, and so on and so forth? So that is kind of like there's like a lot of legal questions, issues, and obviously no one really wants to be the first who's doing this. So
There's a lot of legal issues, I agree, and there's also a bit unfair argument, I would say, because from LLMs and AI, we always expect that it's 100% correct.
Yes.
But from the human drivers will also make failures, yeah, and people make mistakes, and other people die because they are driving too fast or stuff like that, yeah. And I mean, we have cases like this, and it depends if you're in a public area or in a defined area like an airport or like a port or like a factory hall where the company is liable for the environment and for the safety for the workers. Yeah, but it's a topic. Yeah, definitely. Yeah.
So the perfect transition from the first talk to the second talk. Bernard, thank you for your time, and welcome to the stage. And we're talking about sensors in robotics. And please welcome.
Yeah. So thanks again for having me. I'm giving a few examples, I think, from the robotics area. We are a sensor producer, as you can see here in the name of the company or in the claim. And I think, yeah, you made also a good few points in the previous talk. Of course, we will see some training here, some practical examples. So what is this motivation for using AI at all to solve robotic applications? And I will show you a few of examples, not with a human robot, but also with industrial automation. So the topic is that we can increase the complexity of tasks that can be solved. I mean, Marc talked about this thing where you spray color on some things, where you have to drive screw into a working area. And at the same time, AI enable us to reduce the complexity of the solution dimension. Yeah, if we do it in the right way. So that is at least the motivation for us to use AI in robotics application. And I mean, we are not a robotic vendor. We are a sensor vendor, which is kind of, we are the eyes of the robots. So we give the data hopefully in real time and hopefully the correct data so that the robot can act in a correct way. And an application which I want to show you is AI in logistics and dispatch solution. So if you look at the airport, most of people think the airport is about flying, but it's not at all about flying. Flying is, I would say, a side effect of the whole system. So if you look at the airport, it's a gigantic logistic and dispatch area, like a DHL hub or something like that. So you have luggage that gets transferred. You have people which get from one plane to another. You have meals that have to go into the planes and whatnot else. And you have different kinds of goods also from industrial environment. I mean, if you take flight, you won't have dangerous goods in your luggage, and this has to be checked. Also, things like classification. Yeah, if the luggage is transportable, if it conforms to the conditions of the airport and of the carrier, then we have this thing with OCR. So it is necessary to detect the labels which are on your luggage or on your parcel so that they get into the right way. Then we sometimes have flat objects which are difficult to detect because they have the same nearly the same color as the conveyor belt, and they are not very high, so it's difficult for the sensors to detect them. We have different objects. Yeah, we have boxes, tires, bags, parcels which have to be sorted in different areas. And sometimes things are not really separable. So it first appears that they are one object, but in reality, it's really two objects which were close to each other, and we don't detect, or it's difficult to detect the boundaries in the first place. And imagine this conveyor belt, they run at 5 meters per second, 2 meters per second, depending on the size of the airport and the dimensions. And we have to detect it in real time with a high percentage of confidence level, because manual sorting is always expensive and sometimes also no option. And we can also go more into classical robotic applications. You see a Visionary S sensor, which is a time of flight sensor, and a 2D vision video sensor. So it creates real-time video and also the 3D measuring of the objects, and you can apply it in different areas like palette sorting here. We have, or if you have to sort tires or arrange them on conveyor. We have things which are totally unsorted, where robots have to separate goods, and sometimes they are also in these bounding boxes where they, for example, take out the material and then put it into the future production step, instead of having a human here. And all this has to be kind of intelligent, so that we get the right things out of the box, or that we order the parcels on the pallet in the right way, or in a stable way here. And at the same time, it has to be safe. Yeah, nobody should be hurt when he gets into the robotic cell here. And it has to be also reliable, so it has to be running on a high percentage, and the robots should not make failures, and it should not stop. So there are high quality expectations, or confidence expectations. Let me show you another example. We have also a next wave of this visionary sensor that we call AI assistant. So this has a person detection in the sensor itself and a 3D object detection, and everything is in one device, so we don't need external compute power. This is also deployed in rough environments. Yeah, so we have outdoor conditions. As you can see here, we have these building machines here, large trucks or trolleys with dust, with sand, stones, mechanical stuff. We have rain, fog, whatnot else. And at the same time, the sensor has to be reliable, so that we have low false alarms, because when the system stops every 5 minutes or something like that, it won't be accepted by the clients, and also by the people who are using these solutions. At the same time, it has to be safe, so a person here behind such a truck has to be detected, so that nobody gets injured. Yeah? And I will show you that example in a minute. Here we have also, I would say, AI in classical production. So the usual automation area where we sort bottles, or clean bottles, or have to classify woods, or the orientation of a wood, depending on the animal rings. we have this use case where we have to count or separate objects. We'll see an example of that on the next slide. And then we have this inline quality control, yeah, often with a high speed. We detect if the labels are put in the right place, or if we check for deformable objects, if the right things are in the package, or if something is missing, or if for example, the assembly verification, yeah, if the electronic card has all the parts on it. And these are sometimes, if you look at these production facilities, they are producing, I think Krones is producing 100,000 bottles per hour on a single machine. So they are rushing through these sensors very fast. So how is such object detection configured? I can show here an example of a lector. So this is a NOVA application where we train our sensor for a classified object. So you just take a picture and then mark the objects and the approximate dimension here in this picture, and then you train our or refine our model. And you can even test it in real time with a live view here, put additional objects into it and see if it classifies in the right way, and for example add this also as the next or take it as the next valid example. Yeah, you see also in here the center of gravity of the objects, and this information can then be passed to the robot to pick, for example, these apples from the box. We can add also a new class. So a priori, our model didn't know about red and green apples. So we have to retrain it kind of, and yeah, make a second tag for the green apples, and then we can detect them also reliably. Let me look if we. Well, yeah, I think that the rest of the video we can skip, but you see, the training is done nearly, I would say, on the job from the customer, and he doesn't have to program it. He takes some sample pictures, takes them, and then we can run the application. Yeah. I want to show you also here some stuff how we develop the sensor themselves. So this was essentially now the user view. We are, of course, also you have seen there's a lot of software obviously in these sensors, and also on the UI side. So we are, of course, in the sensor itself. I would say the most of the part is kind of classical machine learning. So there are no LLMs running in these embedded devices yet. We are on it, but that still takes some time, and we also still have no agents or agentic AI. Yeah, we have that on the software development side and on the other topics. And I mean, if you look at how we develop software, meanwhile, I think we have gone from these LLMs to over RAG to AI agent, and now we are reaching currently, I would say, agentic AI. Yeah, we have the first systems here with agentic workflows, which enable us to have continuous AI, where we don't program software as it was in the past with high-level programming languages, but we rather described requirements in GitHub issues or whatever, or in a skill file, and then let the robot code or create the software for it. Yeah. And of course, we started also using GitHub Copilot or any other AI-powered code completion. Meanwhile, I think we all know this. You mentioned vibe, vibe coding and vibe roboting or whatever. What we have done is here we have also added AI to the software development to ease the development of control software. For example, we have these edge computing devices. Here's a SIM 2000. You see here, this has a CPU in it, and we can attach numerous sensors, and also use the Signova software that we saw. And we have also Ethernet and IO-Link adapters for the communication. Yeah. And in this sensor integration machine is the name of the SIM. We can make pre-computations or trigger actions, and this is programmed this is coded here with the Lua programming language. So internally for this machines, you as customer and or the solution provider or we as sensor vendor can create a Lua program. And of course, we have also our own frameworks and APIs, and GitHub Copilot, for example, did not know about that. So what we built in the past is a GitHub Copilot, which knows about our Lua interfaces and our architecture. Yeah. So here you previously you had to adapt all our conventions and read the manuals and read the APIs, but with this chatbot or Copilot extension, you have these commands where you can say /teach. So I asked some simple questions about the SIM 2000 application development. How can I use the programming or show me some tutorials, or with create, for example, you can set up initial project, yeah, with Lua code, and with the API it also gives answers to questions you query about the App Engine and the App Space APIs. Yeah? So this helps to program our software, yeah? And it's built with the classical RAG approach. So we created kind of a vector database which learned about all our code base, our APIs, our manuals, our programming manuals for SIM 2000, the programming examples, etc. And this can then be queried with the usual RAG approach, and then we get kind of nice code completion for the programmer. And let me show you here an example where we use Copilot. So I instructed at SIM 2000, how can I set up an event formatter? Yeah? So if we get an event, we can format this in different ways. And Copilot then creates example for us here in a nice Lua code where it explains how to configure the formatter and the protocol. Yeah? And the next thing I want to ask is, what is a virtual communication interface? Yeah, we have our own concept of ports and communication interfaces. This is then explained here. And then I also ask, how can I set up and configure such a virtual communication interface in my Lua code, and then it again generates the corresponding code. So this helps a lot with coding, also for the for clients and for system integrators. Meanwhile, we have gotten further. We have these MCP servers, which are kind of universal plug and play interfaces. Yeah. So the idea is here we have, for example, for these track and trace applications, TTL applications, we call them. Yeah, you know, these reading tunnels where we identify the packages and the parcels and the OCR scanning, and we get a lot of data, or the customer gets a lot of data in such a camera reading tunnel. Yeah, reading rates, failure rates, how much objects did we read today, how large were they, etc. And instead of evaluating this with such a dashboard, we can now, of course, query it with natural language, yeah, or with kind of AI. Yeah, so you have an MCP host, which then contacts here the track and trace MCP server, which then queries the information from the TTL API. And so I can query, for example, this is here, I want to find all targets which are width larger than 1 meter and a barcode that contains the letter A. Yeah, and then it runs this against such an MCP server, and we get back the timestamps and the physical dimensions that we had. Yeah, and the information how did the parcel look like? Was it cubic, or what is multiple flat, irregular, etc. Yeah, so this helps, and AI helps us to get more flexible here, because previously, you know, we built these APIs. Yeah, we built the user interfaces for that, but different users or different customers have different requirements, and here AI enable us to be flexible and get the data so the customer can fulfill his requirements, or his solve his application. Yeah. Of course, we have different workflows with these MCP servers. So sometimes we have human interacting with the MCP server. Sometimes we have agent to machine protocols, or sometimes we have MCP server interacting with other MCPs or APIs. This will come up with the agent to agent protocol. And here we see how the communication flows, and of course we have also to make this solution secure. So we always have to obey things like certificates, authorization, authentication, etc. And that depends on the use case. Yeah, who does the or authorization, or in which part of the workflow. So I will not go into detail of this, but you can look it up in the slides. Yeah.
Hi. In this video,
so what does it
go through
require
the
to
visualizations,
configure such an environment for
first have to
sensors,
log
or
in
the eyes of
something
the sensor? So
higher than
one thing is, for
standard. So
example, we
let's
have to mount it and calibrate it. Yeah. So here
For
you
the
see
mounting settings,
the
I advise you
2D
to
picture,
stay in
and then
continuous mode,
here we
because this
have
makes it easier
the
to see
3D
directly
measurement,
changes
which
you get.
is in the first place
Some
incorrect,
words to the
because we have
visualization
to
you see.
calibrate the sensor to be in the right position. Yeah, and you can configure it. For example, here I have the local set value that gives the depth information here
mode,
in a color. You can configure it and fine tune it. So you see here we have only measurements from 1 meter to about 2 meter, and the the sensor could measure from 1 to 7 meters, but the field of interest is here 1 to 2 meters, so we can fine tune it and have a better representation here. And the other aspect I want to show you here is that we have here possibilities to calibrate the sensor here. Does it look from upside down or from the side? Does it side view? And depending on these measurements or on these positions, we have to calibrate the sensor values.
Or by again,
maybe in future this could also be done autonomous, with comparing the 2D and the 3D picture. Who knows? Currently, we are doing that still manually. Can also apply filters. For example, if you are only interested in certain fields of interest, you can configure, you can pre-configure this so that we can better process the data then in real time.
Dimension the scene.
So,
Bernard, I'm sorry, we can hear the video audio also.
Oh, sorry. Okay.
This value.
Okay.
That's better. If you want just to show us the videos, that's great. You can talk, just perhaps mute this one.
Maybe I stop the video and say a few bits about that. So what we also have is a emulator for this sensors or for the devices. So you don't always have to have a real device, but you can also use here emulation of the sensor and run it with a virtual device. So you connect this with your local
I recommend to use
with the local host
option,
and then you load up the software. And this is now a virtual device. So it's not a real sensor. We have pre-recorded some scenery, and this scenery can then be processed in this virtual environment. So this is enabling you don't have to always have on site at the customer or have a real device. You can also work in this kind of a simulation.
This is still
and I think if you look at NVIDIA, what they are offering, meanwhile, it's there will be great things coming. Okay, let me show you a last example here. This is a safety-related sensor. We see here red boxes and yellow boxes and persons. So this visionary AI is able to detect persons in real time via this sensor, and you are able to define safety areas where people where the red area is where the machine will immediately stop, emergency brake, because if you are in this area and the robot moves, I would say here there's 2 robots, 2 practical robots, there's a risk that somebody will die, and in the yellow area there's a safety area where the robot will slow down. So this is a kind of compromise between safety and availability in this area. And you see, this is a sensor who is mounted at large machines in a rough environment where you have to deal with water, with dust, with fog, with different light conditions, and it has to be very safe. So this is kind of new field also regarding the certification. We have to talk with the certification authorities like TÜV to get these devices certified. And I mean it's still these models and networks and machine learning things are a kind of probabilistic based, and this is some new field, I would say. We have also available here some for the development, some MCP server for configuring this Vision AI sys. So we have the internal REST APIs here are available via MCP server, and so we can also use AI to get informations about the sensor, the system state, define this field of interest or these bounding boxes, etc. Also, we talked in the previous, or we had a topic about test data in the previous talk. That's really an issue. Yeah, let me show here one thing. So what we are doing here is creating test images for our sensors. Yeah, because we are not allowed to take images with persons and also no images in the public area. Yeah, but you know these machines. If you make the surface of a street, yeah, it's mostly, I think, in the public area. So what we did is we took pictures without persons here. You see here an example, yeah, where we took pictures with the sensor camera, and then we use the AI to add persons which are, for example, occluded by an object, by machinery, etc. Yeah, and we use a Google Vertex model to generate here these test images. Yeah, because the regular way we are not allowed to take such pictures. Yeah, and you can also do this, for example, with synthetic test data. But the approach we're currently using is take real world pictures and then add these persons for it. We are also using this approach for this sorting applications in the airport for luggage, where we have test images, but yeah, we invite new things, sceneries that are not difficult to get in reality or are nearly impossible to get in reality. Yeah, and here AI helps us very much in the development. Yeah? So this is the new overview of the how we will configure devices. Yeah, you have things like finding applications, configuring sensors. Yeah, maybe I run the video here. Yeah, so this is a kind of our IoT platform. It's called Sentio Creator, and here you can then. It's not a robotics platform, but it's a platform to configure applications with our sensors, and yeah, for example, make fusion of different sensor measurement data. Yeah, so here you see a kind of different device lists here, Elector, also such a SIM or SIG, and you see here we have also a marketplace. For example, MRM, this mobile robotic manager, is then a kind of domain-specific application. Yeah, the upper three things, app manager, deployment manager, and device manager, are kind of generic applications, but we think also about domain-specific applications. Yeah. So maybe I show the last video.
Is the
here,
Vision AI assist already connected?
shows this,
Yes, the installation was super easy. The camera is just booting and there should be an image soon. See, the camera can already see us in 3D.
And what makes it so special now?
It uses a high-end AI chip and a custom-trained neural network to detect people in all different poses. At the same time, the 3D stereo technology allows to detect any kind of other object. And this allows to give differentiated warnings.
And this happens all inside this camera?
Yes, the Visionary AI Assist combines all its features in a compact and robust housing. This makes it super simple and super easy to set up. And that's not all. The camera streams also a 2D live image to support the operator in the cabin. And in combination with an adaptable field of view, it allows to cover a broad area behind the machine or to focus on longer distances.
What a great solution. Let's take a selfie so I can tell everyone about it.
Okay, dann hängen wir jetzt einfach die Kamera auf, oder?
Ups. Oh, brauchen wir eine neue?
Ach Quatsch, dafür hast du doch gemacht. Now it's your turn. There are many more mobile and static applications. Think outside the box and solve the problems of your customers.
That's nice. I like the idea just to drop and see if it's happening there, if it's just working or not after a while. Thank you very much for your interesting talk. So now we bring in also Marc back on stage somehow to discuss the whole questions we got already. So what I was expecting somehow to see sensors, and you have pointed a lot also on AI stack, somehow what you have done there. So on how you build, how to learn, how to use also AI back 5 years ago, as I was. Was it right? What I was seeing was 5 years ago. So you started already, and then you're going right now. We're also talking about the agentic workflows. What is also another topic, really interesting. This one, but if we compare what Marc was saying earlier on robotics, running robotics. So the step, if you are using sensors to bring this data to the robots, that is where you're pointing yourself with your company somehow. This SIG. Is it right?
Yeah, and this is already using, I would say, machine learning and in the future AI to give the robot the right data, so that we filter out uninteresting things. So that it. Yeah, we had that paper. Attention is all you need. Yeah, we need attention for the right things, and that's it's not trivial, as we can see with self-driving cars. We have them now for I don't know when started Google car with 15 years ago, something like that, and now we have the first Waymos running around. So it takes some time, but I think we'll go there. Yeah. We'll be there.
Somehow it's really great experience if you are just going to your app, just asking, I need this route, just going in your car, say start, and then it's driving somehow, and you see all of the obstacles. We were been there at the Ignite in San Francisco, and this was crazy experience somehow if you compare this to Germany. So the car was there, you're driving, there's no interaction somehow inside the car. That could be a bad driver as a human, could be a great driver as a human. So you have simply the easygoing experience, simple experience. That is always the same. And you get to your point, and that's it. Well, the people also struggling, of course, if you're driving the autonomous car, if they are in an environment that needs your sensors, but also if something new is happening. So a new car is pointing there. You see all of these Waymo videos. Two cars are going to each other, and then they need to brake then one route so the other can pass, and so on. So that is something what I think it's really important also to understand, that we are still, as Microsoft would say, we are still in the preview. and
Yeah.
not in production somehow. We're still learning this way. So what you were talking already about these features, Mark, you're trying to enter as a startup a market. So somehow you're not set for 20 years right now. And also, Bernard, if you're talking about the sensors, what you need also, it's happening also in a really quick way. Then you need to recognize through the sensors whatever obstacles, apples, also something like in the fabric, some other objects and so on. What I was wondering, are you guys building like twin systems, digital twin? Yes, no?
Yeah, I
Perhaps
mean,
you should.
you can argue with these emulators I showed you
Yes.
are kind of first digital twin, which simulate kind of the behavior, yeah. And then you, of course, you need, if you want to plan it in the, or mount it in the plant, you need the CD drawings and all the plugs you have to connect, yeah. But I think we are going there, yeah. And people are they want to virtually test if the application can be solved with solution A or solution B, and not build it up in advance, but simulate it, yeah, with restrictions, of course. Yeah, we cannot simulate all effects, all physical effects, maybe, but yeah, I think it helps, yeah.
Yeah. I mean, yeah. So obviously, we for the tools or the hardware that we build, we do have twins. And as I was showing in one of the slides, for robots, like industrial robots, there are twin solutions. But I would say, because I mean, I'm coming from the IoT world, right? And digital twins in that sense is something that is really common, like for years now, in that sense, right? But when you think of robotics, it feels rudimentary what these industrial robots consider as their digital twin. I would do a lot more, use a lot more sensory data, force feedback, and all these types of things. They're probably there, but they are like not really taken into account, and all these things. And yes, there are these robotic solutions and these gyms that take all this into account. But unfortunately, that's not like what everyone would do the entire time. It's kind of like, yes, those tools are there, and if you really want to tweak your robot or whatnot, then this is all going to be used. But especially in industry where you have different geometries, for example, people do not go too deep into this. They are just happy if they have their robot trajectory for this particular path, and then they're fine. And that is basically, that hopefully gives them enough return of investment soonish, and not go into all the fancy things of digital twins of entire oil platforms and whatnot, what we are seeing in the IoT world for decades, literally. So unfortunately, it's not as common or not as widely used as it is in other fields.
Okay, another question. Thanks, Renata, for joining us. Really cool. Are you putting something like no-code, low-code solutions also to run your robotics ecosystems there, or are you building all of this stuff on your own, completely from the whole stack?
You mean, I mean, we provide a no-code solution in that particular sense to the companies that we support.
But are you itself? You're using itself also in another company, or you're building from scratch?
No, we are a bunch of code monkeys in that particular sense. We just
you're doing completely by your own.
We are an engineering startup. Yes.
Well, we are doing we're using the tools ourselves. So this DTEC, what I showed you, for the Nova interface is used by the development team itself to train new images, and we are also considering using AI to identify new objects. Yeah, for example, if you think about the example with the green and the red apple, yeah, if there comes a banana into it, why not identify it with a vision language model and
sure.
tag it? Yeah. So
if you have your data already, so back to the data problem somehow, if you have your data for bananas, you can easily recognize that is a banana, whatever. I know, for example, for 90% or perhaps 80%, that could be a banana somehow. You are not going every single time or 200, but you can recognize, okay, that could be something, and then you can react on this. But from Bernard, from your stuff, if you're going for the sensor data for the first time, you have never seen this scene. So I am recognized Marc was going to this system, and then first time we never seen this scene. What is the process you are learning this one?
What do you mean with scene?
The environment from the robots. The scene, I'm sorry.
The scene. Okay. Yeah, I didn't show that stuff. We have, meanwhile, I would say it's still maybe in early development. We can take pictures of sceneries and then create a virtual environment where we put in it. I mean that's coming with Isaac and all that NVIDIA environment or modeling stack. So that's possible to also to mix and match meanwhile productive and simulated data. Yeah. So not only could we use these emulators, but we could also use real data to feed in into. So it's I think that the world are merging.
Yeah, that's compared to the agents where you get some LLMs that are already have some data, and then you're fine-tuned with the actual data you're seeing during the production somehow.
But you already have the data because like this digital treasure trove was already available, right? So someone found, I don't know, random 300,000 pictures on Kaggle and used them in order to train the model, legal or not. That is not the question here, but that's kind of the challenge. And I guess Bernard or SIG probably has the same challenge, right? So if you build these sensors and you put some machine learning into it, you need this type of data, right? So for example, the camera that you had that you mount in front of the car, I mean, it needs to understand this is a boulder or a rock and this is a bicycle or whatnot. And I need to stop when there's a bicycle, but I can go if that is like a boulder that is only smaller. And that is kind of like you are almost in the same position with that, right? So you need to get the data somehow to train this and get your camera, make your camera smart.
Yeah.
It's really cool conversation, but I think we are a little bit over the time right now. And perhaps we need to wrap up to the summary on this one. That was a great AI TechDay. Thank you both for your time and your presentations on robotics, and also two different, perhaps, seen what we have done here on sensors, and also also from Bernard and also from Marc on teaching robots. So both together, you two together, could build also a system.
Would be a good connection.
Just saying. Thank you very much for joining us today, and see you next time. Thank you both.
Again, thanks for having us. Bye.
Bye.